Hello, Cardstack community. I'm Chris C., the founding director of the Cardstack project, coming to you from the land of the Web3. Today, we're going to tackle a topic that's very dear to my heart. We're going to talk about the work we've done in Boxel, which was called the Cardstack framework in the past. But there was a lot of concept about making something even more than just a way of building software, but an actual new abstraction that allows users, designers, and developers to find a new way of working together to assemble software from parts. So we're going to talk about composable apps. This idea that the application, even though they are very separate, people have different tabs or different apps on the phone, they work together, but they're not really composable as you would expect that copy and pasting within the document will allow you to do. So there's a lot of principle that at play here to make this happen, and we're going to jump in to talk about how the Boxel abstraction or this idea of Boxel help make that happen. So let's start with the word Boxel. So Boxel comes from the word box element, and that's inspired by the word voxel, which was famously introduced to the masses through Minecraft, which is through these little boxes or these volume elements, you can assemble not only beautiful structure, but also through things like redstone, very complicated circuits and kind of functional components where switches happens and you trigger a card and then something happens, where you can essentially almost like program an interactive environment just by placing bricks in a particular 3D space. And the idea here is that this type of composition is emergent, where as you put more and more things into the space, it does more and more things. And as long as you follow the rules of Minecraft on how things work, you can create these elaborate things. And we want to extend those concepts to the web, where in the web, there are things like boxes, where you go to a application and then you see these boxes that are representing a field, a form, a page, a card, something that you can move around. But these abstractions are not real. Kind of like going to a game where you see many objects and non-playable characters, but they're not really assemblable. They're already there. You're kind of just in a movie scene and stuff like that. Minecraft's a little bit different. You can actually manipulate that environment. As a user, once you learn the rules, you can actually create everything that you see. Could we extend that principle to the web using this idea of boxes, this CSX box element, which is for developer, assembling these type of spaces to make it together? So this icon is really showing that boxes on the web are very much nested. So you can put something inside something. A box can contain a box. And more importantly, a box can also kind of wrap another box to create an abstraction. So if you have a form that contains 3 fields, once you fill out those 3 fields, that form exists on its own. It's kind of like a folder. Once you have files within the folder and then you zip it up or drag the folder, everything in it goes with it. And that basic principle of nesting creates this mobility that allows us to really think about how software can move and how software can be constructed from these parts. And more importantly, because we can use the web, the hypermedia model, to navigate in and out of these kind of nested components through modals, zooming out, and like right click on something, we create this 3.5D environment that gives us a building block to tackle some of the complexity of software that has happened over the years. So let's start kind of layer by layer, level by level, figuring out what are we actually using this Boxel idea to simplify the complexity inherent in software. So we're going to start with accidental complexity. So let's say you want to build an app. Either you or your team or your developers say, I want to build an app, so you decide what stack do you want to build this app on. It could be JavaScript, it could be Ruby on Rails, it could be other types of frameworks and stuff like that. And then you decide, once you decide what stack you want to build it to, you want to say what kind of code I need to write at what part of the stack. Some programming language are full stack, some of them are just back-end and front-end. So basically, you want an app, you choose the stack, and then you write the code. And the developer who write the code generally will say, well, it's not just the stack, it's also the libraries that we can use in the stack. So this idea is that code that's been written by other people, so this is kind of the open source ethos, is a very important part of reducing the amount of lines of code you need to write by reusing the stacks and libraries that's there. So if you look at a typical application, once you choose an app and you kind of put the libraries together, you get to reuse from this amazing open source ecosystem, front end stuff like template, how you do with state management, the UI components and design system you use on the back end, what kind of cloud, what kind of databases, how do you generate the APIs, and depends on whether you're using a monolithic framework, so which is a framework that includes all of these things, or you use a kind of mix and match library approach, you would come up with a different set of things. And so let's say you choose JavaScript on the front end, you can also choose JavaScript on the back end. What you write to create the end user application is the actual business concept, the domain logic of, let's say you're building an invoicing application. What is an invoice? What's a customer? How's a vendor? How do we deal with payment and amount? And then based on some sort of front and back end code that manifests themselves in the front end. Now, if you were to choose a different stack, or you were to kind of have a developer say, I want to rewrite this backend, you actually lose a lot of the code. Now, the open source bits is reused. You just use a different set of stack and libraries from the web, from package registry, from the greater GitHub ecosystem, but you have to rewrite all your stuff if you want to change what you do. So these things, if you're writing a social application, you will have a different set of codes you need to write, and all the time you just have to start over. The only thing that really keeps going is the growing open source reuse code base. The stacks and library gets richer and get more contribution, but the apps and the code, the logic you write, tend to be somewhat ephemeral based on each person, and it gets written over and over and over again, and developer knows this, right? So they trade on the fact that they know how to use the stack and library, and they work on a kind of a customized basis based on the app requirements. This consequence of that is that a lot of the longevity of software is in this reuse, a system of reuse around these stacks and libraries, which is actually somewhat meaningless to people who are not developers. The part that's meaningful to most people, which is this part, the app and the code that implement the app, which we call the domain logic, domain model and business logic, that stuff, which is most important to people, are typically kind of not part of the open source ecosystem. So what we want to do is to say, what if we can reuse not just the stacks and libraries, but we can also reuse the apps and the code and combine them in the same way that developer combine the open source library, but around the business domain and logic. So if you build a social application, I should be able to use your components in your social application in my AI application to use social feed as a way to distributing ideas. Currently, that's not really possible. You rely on running apps like Discord, and then you use the API, but it's not really composable. You're really a guest on their server versus really incorporate elements of those apps or those business logic or those domain model into your app. But if we can get the entire thing, the stack, the app, the library, the code, and the front-facing user component that users have learned and loved, and make that truly composable and open source, then we have the opportunity to move away from this accidental complexity where we have to redo the whole thing over and over again using open source tools, and create a real true reuse around this idea of distilling the actual app into its essential complexity, which is the second level of what we're trying to do. So what we have in a stack, let's say you agree on a set of stack, some JavaScript tools, some databases, stuff like that, all the stuff that was in the Boxel library. Let's assume we chose a decent subset of them. So it does the job, it gives you hosting and URLs or runs on your browser, whatever it might be. Assume the stack is pretty decent and pretty complete. What you're really building on top of it when you're building an app is to build the domain models. So an example would be if you're building an invoicing application, you have a concept of invoice, you have a concept of customer, concept of vendor and payment, like what we did before. And there's some relationship between those concepts that links them together. And with this particular approach of domain model driven design, you can then say, okay, for each of these domain model, I need to write some code for it that makes it particularly unique. And then based on that code, the user creates some data. So what is in this code, right? The code is really have to cover a couple of things. It has to cover what is the structure of an invoice? What is the field that goes into an invoice? What's the field that goes to customer? Name, address, vendor, logos, and payment terms, whatever it might be. The template, how does it look? Maybe it's very, very customized template because you want it to look a certain way. You want your invoice to be like theme to your organization look and feel, or you don't really care. You just want it to work like for a particular vendor record. You just want to make it look like a CRM, Salesforce application type of thing where you just want to have a basic thing. But beyond the template, you want to decide what kind of business logic it needs to be. Now, there's not a whole lot of business logic in things that doesn't do anything. So that there might be some formulas that's like, okay, calculate this based on discount. So there's some basic business logic for what we call computer property, which would be similar to Excel, where you have formulas. But as we see in a little later on, there are some times where the business logic is interacting with external system, let's say payroll system or payment system, where you have to encapsulate a little bit more. But let's stick with like these basic ideas of these business entity. So if you look at vendor, if you have a stack, and this is something that we have implemented in Boxel, the data is just some JSON, which is a representation of the data. As the data then uses the schema, which is defined in a type system. So there's a variant of JavaScript called TypeScript that allows you to declare what the format and field and type of things are and how it's structured, and it allows you to essentially share those type definition with other people. So if another application is using the concept of vendor, they can know what is fields in the vendor, and in a way that's very coherent with the way your development tool works. The template, we use a template language called Glimmer, which is from the Ember.js project, which is a type of template language that allows you to embed within this definition file very specific, very easy to use tags and helper function that allows you to loop through these things to create beautiful looking application. But it's encapsulated within this domain model of vendor. So you can make your vendor template look very different just by modifying how the Glimmer template works. And then any additional business logic is JavaScript. What's nice thing about encapsulating this domain model as this concept of Boxel is that this stuff all runs on a similar stack or the same stack. Once you define this set of JSON, TypeScript, Glimmer, and JavaScript kind of domain model, your browser can run this as a kind of local application, or you can host the same stack on the cloud, and then you get the benefit of a hosted URL to navigate to in a database to make searches faster. But the stack is essentially ambiently available. It's like running a game engine on a computer, and you just kind of load the scene onto it. As long as you have that game engine, you can actually see all this information interacting without having any external dependency that is accidental. So with the stack underneath it, the runtime of Boxel provide that uniform service. But if you look at actually what the code looks like, it's pretty simple, right? So when we have the schema and template and logic, they all go into one file. You talk about what kind of card you're using as a field, and you define how those template and what the fields are. And that's the definition of your schema, template, and business logic. And once you've defined that, other version of this, like a new invoice, you don't have to repeat the code over and over again. You just have a data-only Boxel where it uses the definition that has already been seen as like, oh, I want to use, or the word we use is adopt, that particular structure. And this is the unique data that makes this particular information unique to my use case. But if you look at it that way, the surface area is now a lot more even, right? So instead of having like an app and then you have to go to the app and then you have to like create an account to create an invoice, the invoice is just a file, right? The actual definition of the logic and the schema is just a file. And then on the same realm, you have the ability to create other files that have the same information. When you actually execute this information, you don't actually see the seam. So you're looking up this idea of an invoice, and you're trying to link a vendor, which is a file, on this particular situation together. You just search for the file, you add it in, the same way you copy and paste a thing. That's how you associate the two files together. What's underneath here is just linking a file and like putting embedding a link to that file within the file, an invoice file. But what is really cool about this idea of using Boxel as a Boxel model in the web is that even though what's going on is just manipulation of files, it looks and feels like a full-fledged SaaS application because the template is based on a web platform and has that rendering. So we have essentially creating this essential complexity in containing with this idea of Boxel, which contains a template, and then we allow user to do very simple operation to construct these fairly elaborate layout that essentially is a way of just navigating this set of files interrelated between each other. And with this basic idea of structure and layout, we can look at some sort of emergent complexity that comes with the trade-off of software. Whenever you're thinking about software, you have this challenge of saying, do I want to use something off the shelf, slap it together, reuse it, and write no code as all to get faster time to market? Or do I want to tailor an application to my specific needs and then integrate with my complex backend systems and then craft something for my customers so that they have a branded experience, or for my employees, or whatever it might be, so that they can kind of be guided in the workflow and make sure you don't accidentally do the wrong thing. So you kind of handhold them through processes as well-defined. So the time to market and fit to purpose is always something you kind of have to decide upfront, build versus buy, and then you have to live with your decision. If you use off-the-shelf software and then somehow you extend it beyond its capability, then suddenly you have to switch all over and start from scratch and do custom development to optimize or fit for purpose. But with Boxel, what we can do is we can actually kind of have our cake and eat it too. We want to have a system where people can first optimize for time to market to reuse existing Boxel has already been created, right? So like a basic definition of something that has been shared by the community, like open source, use things that are already out there. And then if you feel like, oh, this is not doing the thing I wanted to do, I need an extra field, I need an integration, I want it to link to some internal records, then you can kind of make a copy of that template the way you would like copy and paste an Excel template and add your own formula, and make it so that it can be more custom and you can write special JavaScript code to connect in a certain way. So let's take a look at a concrete example. So let's say there's a public catalog, that exists, much like a package registry for developer where they submit open source software and then you can use them. There's a standard invoice that everybody's like, hey, I wrote an invoice, it's pretty good, it complies to everything that people expect from an invoice. So there's some public code you can use. And there's also vendor and other payment things like that has been published. So if you're a company who say, oh, I want to build a system that deals with invoicing, you can just say, oh, I'll accept that as my input. So anybody who wants to send me the things, I would accept this file format, the standard invoice file format. And then you're up and running. Your time to market is like a minute, right? You just allow people to submit this particular standard invoice that is shared as public code for people to give it to you as a way to submit an invoice to you. And you can also say, oh, and I also submit payment through cards. And then say, okay, there's a very nice implementation on the public registry. I'll just accept that as well. So this is time to market, right? But when you say, oh, you know what, I really need a special field for the invoice so that I can have my own internal approval rules, then you can go ahead and say, oh, let me go ahead and adopt this standard invoice, which is a way of saying that I'm going to make a copy of that thing and say I'm going to add additional logic and code while maintaining compatibility with this invoice. We don't do inheritance for developer thinking we're doing inheritance. It's a compositional pattern where you can add to it, but you can remove from it. So this logic is additive. So any additional approval rule doesn't mean that the invoice is not still compatible with the standard invoice that's been published publicly. The same thing you can do, like if you have a certain reward card and you have a card issue API where people can redeem their points and loyal customers, and it's a different type of system. It may not be the same, but you might want to use the same UI elements. You want to have it in the same drop-down box. So you create a new card called reward card payment that allows people to use that particular element, that box element, in a compatible way with it. And that's you adopt and you add to that. And once you're in this catalog, you have now a much more customized application that allows you to organize your internal approval workflow or manage your internal redemption points. But if you're dealing with a vendor and they say, hey, I want to, you're hiring someone to do something and they want to give you an ability to either invoice them or they will invoice you. That means that they may not know your internal customization. But here's the great thing. They can pull from the same public catalog. And all you have to do is find a way to convert your own catalog, your own invoice into the standard invoice and then send it that way. It's almost like removing fields that may be private to you before you send it. And that whole system, developers know that as casting. You can take one type and cast it into another type of type if there has common fields and whatever it might be. So this type of Dan casting gives the ability for compatibility to be maintained even your customization. This is unlike when you're building system where you have make customization and it makes it not compatible anymore. But if you, let's say, support an RSS protocol, something like that for syndication, you can customize the look and feel of the block and still be compatible. And that's really the way we want to ensure that users can feel confident that if they add to these Boxel, they're not actually moving away from the community. They're actually extending and emerging new capabilities. And by the way, if you believe that you have extended that invoice in a way that's useful to the community, you can submit it again, and then there may be a special type of invoice that have, let's say, payment using Web3 and crypto wallet, and that becomes another common shared reuse structure that's available to all. So in the Boxel ecosystem, there's two main verbs that we want to have developers kind of think about when they're thinking about composing. One is when you're creating your own application or forms or layout, you want to say, what do you accept? I accept images, okay? I accept the media image type. And then that means that you accept anything that is that has that type, including if another developer say, oh, I want to adopt this image type to do a generated image, so I want to do some AI generated image, but it's still kind of adopting from the image type. So it is as mobile, that particular unit, as the image type itself, because it can be downcasted from a generated AI generated image back to regular image, and is accepted wherever image upload is allowed. So this idea of start with compatibility and then maintain that compatibility, even the extended, is a really important aspect of Boxel, not just being a way for one developer or one team of developers to do, but it's a way for different people in an open source kind of sharing to be sharing the logic, domain logic that would be necessary. So I know this is quite abstract, and this is a particular example of the idea of these kind of different types of Boxel kind of nesting within each other. So you have this basic idea of an address, right? So who really wants to implement an address again? So if you're doing a subscription and you need an address, you just say, I'll take the public definition of an address card. I'll accept that, right? And then that allows you to have all the fields that the address card has. And then later on, if you want to use and save this address, you might decide that, oh, I have saved this address, but I want to add some annotation. You can adopt that and add some field, and that doesn't affect the company or the public catalog. So a personal user can adopt that and create their own variant of that. And the company would accept that because it still can be downcasted to the basic address, and then that can be nested further to memorialize into a receipt in the future. So this idea of types goes beyond just the idea of a very low-level type like strings and stuff like that, but it can actually compose all the way up to receipt, and receipt itself is something that can be accepted. So that for refund, for like an insurance claim, you can just accept a receipt. So the accept system allows you to keep building up like the nesting aspects of further and further up to create this kind of emergent complexity that's still pretty simple because you can click on it and see what the root of the thing is. So once we have this basic compositional language, then we can figure out how these kind of nouns can essentially orchestrate the type of very complex interaction that software needs to do, which is I need to talk to this server, talk to this API. How do you really do that with just essentially a structured language? And that's where we have to look at Boxel as two types of Boxels. The first type of Boxel that we have seen so far are called noun Boxels. They are entities that are structure and layout, and it just is. It's like a document. And there's another type of the voxel, the verb voxel. And they basically allowed you to wrap the business logic and integration and say, okay, I want to do a thing. I want to pay a person. I want to save this. I want to publish it. Well, it depends on where you're saving to, who you're paying, what method you're paying, where you're publishing to. The type of API calls are dramatically different. So look at an example of invoice. So I can have an invoice card that define the structure and layout, but then I have an action like a pay, this is the verb, that will do something with it. And what happens with Boxel is that you essentially put them together. So you basically send the invoice into a pay action. The pay action acts like a command line or like a function and say, okay, I'll take all the information you've given me via invoice, and then I'll do something with that information. So it has an understanding of how to essentially pick up fields from the invoice and say, okay, what's the amount, what's the denomination, who is it going to, and then actually execute that command. And the result of that would be a receipt, which is now. But this idea of action card being its own hierarchy of catalog allows us to say, okay, there's not only one way to pay, there's like 150 different ways of payment in the universe, not only of TradFi, but also obviously on the crypto universe, there's even more place to do it using wallets and stuff like that. Each one of those things comply or adopt to the same pay standard, but they have their own extra fields that is unique to itself. And combining a bunch of invoices of different type and then the payment of different type, some of them are compatible, some are not based on what they accept. But if you can put two and two together, suddenly you have this ability to do this relatively sophisticated interaction that is just putting two things together. So again, kind of abstract. Let's look at an example of what kind of voxels are there. So this is a board of a voxel that is kind of just some examples that we have used internally as guidelines of like, okay, we want an application that has all these types of capabilities. So what are the units of composability? So to be more concrete, contents are pretty simple. Text can be a voxel, rich text can be a voxel. You can make a document out of a text as a title and a rich text, and then you can make a blog post out of that information. So this is just composing the structure using the nested voxel. But when you save something, right? You save a local thing. That's when you call an action, the verb save. That means if you're saving locally, it means that that save card or the voxel that implements that logic have the ability to understand how to write to a file system. If you're saving to a server, it needs to know the API. It may require you to have an API key. And publish may be different. You may be saving locally and then publishing to a database, so it's live on the website. And that's two completely different set of orchestration and logic. But very similar from an end user point of view. I'm giving you a blog post, save it. I'm giving you a blog post, publish it. So this idea of inversion of, what is nesting what, so the noun become a parameter to the verb, right? Kind of like a command line, you're passing a thing in. It's pretty clear here. So there can be many ways of publishing, depends on what type of backend is going to. And if you look at the invoice example we're talking about it, there's an invoice and then there's a way of doing payment. And this payment is could be a TradFi payment. But if you're using some sort of crypto address as a payment, you just use a different payment card, take the same invoice as a input. So it would take the same amount, but it may actually convert it and translate in a certain way. And that's actually without any redata entry, because the pay action understand the concept of amount would exist in a more normal, traditional kind of credit card payment or ACH payment, but also exists in the thing. So the denomination in account has to be a common concept between two different applications. And that's really the important part about Boxel, is that we want application as they go into different domains beyond the traditional kind of SaaS model to agree on the basic principle, what an account is, what an amount is, what a denomination is, so that as we move methods of interacting with protocol from Visa to EVM or something like that, that you can still maintain the basic logic of what an amount would be. And that is only possible if the code is shared. And that's why it's important for these lower level things. I'm not drawing this in nesting way, but they are essentially nested in the UI, but they're pretty flat in the way they're defined and submitted. And that's really where the composability is the most powerful, because any developer building a new application will look at the catalog and say, what can I begin with? What of this board can I use so that I can just extend the new feature unique to my either protocol or particular platform I'm doing it. So as we mentioned earlier, generated image is something like for AI or something like that. That is just an image. It's just a dApp from image, and you have a generated image. The input of that is not some bitmap or something like that, or maybe have it, but it has also a prompt related to it. And then when you are able to share the information, any image compatible system will accept that. Except when you actually send this over to the degree that it's published in a public catalog, you can actually see the code behind that. Not only the code that, the prompt, but you can actually see the logic of the either the generator, how it calls the API, or maybe some of the rules that used to construct the particular prompt. And that's a really important thing about Boxel, is that every Boxel relate to an open source implementation of the code. So you can always view source in a way and modify the source. So as a developer, any media you see, any actual representation of Boxel you see has source code associated with it that you can change and publish. And that's a really powerful way to ensure that we don't lock in to the logic just because something cool is going on, but you don't know what's going on. The actual definition of the Boxel is shipped with this data, or at least even if it's not shipped with in a JSON format, it's linked to it and you can go access it. And finally, if you look at it from how this code is made to be, you can essentially submit Boxel that you believe are useful for other people. So you might be making Boxel by adding fields just for your own use, kind of like your own Notion page. But you can also publish it as a template. You can publish it to the catalog and you can get approved, and then maybe some rules for reputation or staking that determine whether someone can or cannot and pay a fee to make sure it gets reviewed by different people. You may not get into a deny and allow list. And these kind of things are just gating the movement of a Boxel from your own space into this public space, which makes it much more accessible to other people. So we have essentially allowed people to adopt from a very safe set of Boxel. Because it has code involved in it, you may want to make sure it has no way of doing malicious codes, and maybe data only, and it extends without any libraries that's not approved, or it doesn't add any code beyond what the stack provides. These are all rules that allows you to control the safety. When people say, I'm just going to use this template willy-nilly, you want to make sure there's a curated catalog. And that curation is something that is outside of Boxel. Boxel doesn't really care. It just finds the Boxel in a particular realm and some particular area. But as we move to an ecosystem where we want people to feel safe in reusing and sharing, there is a relationship between Boxel to both curate, so using token curator registry, this idea of what is appropriate for a task, and maybe adding metadata and making sure that it has enough metadata to be valid. And that type of catalog allow it to be monetized. So instead of saying that, oh, I'm just going to look in GitHub or some registry for the things, it could be packages of application. You can one-click install Boxel for B2B or something like that, and then it in case. And that type of bundling is monetizable with us using subscription fee or licensing fee or some sort of donation or grant. And we use Champa protocol as our revenue distribution, reward distribution protocol to make sure the people who build the Boxel, if they opt in, can get a slice of the value they create to the overall ecosystem. So hopefully that reward incentivizes additional development of Boxel so that we can essentially create an open software ecosystem where the unit of assembly make way for this idea that the continual growth of this set of libraries or catalog is because people are not only getting faster time to market by using what's there, they're getting the ability to customize it because they have the source code and they can extend it, but they can also monetize if they believe what they have extended and made is valuable to others. So it becomes part of the commons, and not just a commons that requires kind of like externality of like, big tech company to fund it, but actually part of an ecosystem that using the economics of the ability to govern and observe the interaction to make it so that it's sustainable. So this idea of Boxel is one of the three projects that it's dear to my heart and really important to allow for that composability. And Champa is about revenue distribution, and then obviously Cardstack is about using the power of community to be able to curate and find the best way to put the right type of tools in front of people with those tools being as composable as anything the world's ever seen. So I hope this was helpful. I mean, obviously, I'm covering a lot of topics around Boxel, which is a big concept. We haven't talked about the design elements of it, how the user will experience it. We're working on the content use case to get the system of movement between the realms, which is the way we deal with saving and publishing and promotion from something you're working on your computer all the way to a live website, kind of figuring out how that migration or those workflow would happen. But as a fundamental concept of Boxel, I hope that the concept of nesting, adoption, and accepting, and that type of layout customization that exists makes sense to people. And the idea that the primitive that's small, the simple primitive of Boxel, is actually tackling a lot of complexity that's inherent in the craft of software and engineering that we have now. And hopefully, as we see that we want to really engage a larger group of people to build to this thing, there's essentially a need for protocol for composability on the application layer. And I hope Boxel can become that protocol for composable app that allows for a explosion of value and sharing beyond just open source library and cloud service. That the application logic, the thing you care about, the app that you want, is being shared in a modular way, and everybody can be a creator, whether you're a coder or non-coder itself. So thank you very much for your time and attention. The next talk will be on Champa, about how we can use a basic idea of off-chain compute to evaluate the contribution of each person and then provide reward to them using a efficient way of distribution. And that's a really important companion to the way where the value is created through the open source software. And so we want to make sure we reward people for that. So that will be the next thing. And until next time, take care.